Welcome to this guide on the determination of available micronutrients in soil, specifically focusing on the DTPA method using Atomic Absorption Spectroscopy, or AAS. Understanding the availability of essential micronutrients like iron, manganese, zinc, and copper in soil is vital for crop health. We use Diethylenetriaminepentaacetic acid, or DTPA, as a chelating agent for this analysis. Let's first understand the core principle of the instrument used, Atomic Absorption Spectroscopy, or AAS. Gaseous metal atoms, typically in a ground state, absorb radiant energy at their specific resonance wavelength. This is the same wavelength the atom would emit if excited. When light of this resonance wavelength passes through the flame containing the sample atoms, light is absorbed. The degree of light absorption is directly proportional to the number of ground state atoms present in the sample. Next, we move to the preparation of reagents and the standardization process required before sample analysis. The DTPA extractant, a solution of DTPA, TEA, and calcium chloride, must be precisely prepared. A crucial step is adjusting the pH to 7.3 using dilute HCl just before making up the final volume. Standardization is achieved by calibrating the AAS instrument with 4 standard solutions for each element: iron, manganese, zinc, and copper, and plotting the calibration curve. Now let's detail the soil extraction procedure, which is part A of the analysis. Start by accurately weighing 10 grams of your soil sample into a 100 milliliter plastic bottle. Then, add 20 milliliters of the DTPA extractant, maintaining the 1:2 soil to DTPA ratio. Shake the mixture vigorously for 2 hours on a mechanical shaker at 120 revolutions per minute. Afterward, filter the solution using Whatman No. 42 filter paper into a 50 milliliter beaker. This filtrate is what you will use for micronutrient measurement. Moving to Part B, the procedure for element analysis using the AAS. After calibrating the AAS, introduce the DTPA extracts into the instrument. Carefully record the resulting concentration reading, denoted as R, for the element being analyzed. Repeat this analysis process for every target element. If any element's concentration exceeds the calibrated standard range, you must perform an appropriate dilution and refeed the sample to get an accurate reading. Finally, let's look at how to interpret the results and provide recommendations based on the findings. Calculate the DTPA extractable micrometals in milligrams per kilogram using the formula R times the volume of DTPA added divided by the weight of the soil. Use the provided classification table to determine if the levels are low, medium, or high. If micronutrient levels are low, advise farmers on specific additions. For example, if iron is low, recommend 50 kilograms of ferrous sulfate per hectare, and for low manganese, advise 10 kilograms of manganese sulfate, generally applied once every 3 years. For low copper, 5 kilograms of copper sulfate is recommended.